Welcome to Bankers Rankers. In this video, we will discuss a very important topic, simplification and approximation. We have extracted all the questions asked on this topic from previously asked 39 question papers. In order to download the worksheet with all the questions arranged topic wise and year wise, join our WhatsApp group Bankers Rankers. The link of the group is given in the description box. Based on these questions only, we have structured our lectures. All the questions can be broadly grouped into 4 categories: surds and power, bod mass, ratios and percentage. Out of these categories, question from surds and powers comprises 40% of total questions. So we will start our discussion with surds and power and slowly move on to other topics. Surds. Surds are number left in root form. They can be square root, cube root or any fractional power, positive or negative. Whereas powers consist of only positive or negative integer as the superscript, such as squares and cubes. Question based on surds and powers which are asked in exams can be broadly solved using 4 concepts. In this video we will explain the concept of squares and cubes. This question was asked in IBPS Clerk Pre 2016. Now the important question is, can I solve it in 30 seconds? After watching this video, yes, you can. Squares. The following table lists the squares between 1 and 36. Now one question which every student wants to know is, should I remember all these squares? If yes, then up to which number? I will tell you the answer after telling few tricks to find the squares. Trick 1 is applicable for number whose unit digit is 5, like 5, 15, 25, 35, 45, 55, etc. Now let us assume we have to find the square of 15. So 15 square can be found as follow. At first write 25 at the end, then 1 into 1 plus 1, 2. So 1 into 2 is 2. So the 15 square will be equal to 225. Similarly, square of 25, write 25 at the end, then 2 into 2 plus 1, 3. 2 into 3 is equal to 6. So we can write 25 square is equal to 625. One more example, 35 square. 5 square is equal to 25. 3 into 3 plus 1, 4. 3 into 4 is equal to 12. So your result is 1225. One more example, 65 square. 5 square, 25. 6 into 7 is equal to 42. So your result is 4225. Last example, 95 square. 5 square is 25. 9 into 9 plus 1, 10. So your result is 9025. Trick 2. According to trick 2, we can find the square of any numbers lying between 1 and 99. Now let us try to find the square of 23. 23 square. What we will do, we will write the square of 2. 2 square is equal to 4 in 2 digits, therefore 04. Then 3 square is equal to 9 in 2 digits is equal to 09. So finally the result will be 0409. Now we will multiply 2 and 3. 2 into 3 is equal to 6 and double it, that is 6 into 2 is equal to 12, and we will write it below 40. Now we will add them column wise. So our result is 925, that is 529. One more example, 87 square. Square of 8 is 64. Square of 7 is 49. Now 8 into 7 is equal to 56. 56 into 2 is equal to 112. Now we will add it. 9, 426, 415, 617. Your result is 7569. One more example, square of 66. 6 square is equal to 36. Again 6 square is equal to 36. 6 into 6 is equal to 36 into 2 is equal to 72. So your result will be 6. 3 plus 2, 5. 7 plus 6, 13. Carry 1. 3 plus 1, 4. One last example, 39 square. 3 square is 09. 9 square is 81. Now 9 3s are 27. 27 into 2, 54. Now adding them column wise. 1. 8 plus 4, 12. Carry 1. 9 1 10 5 15. Carry 1. 1 plus 0, 1. So your result is 1521. Similarly, you can find the square of 92 and 54 and all the squares between 11 and 99, and you can cross check it. Trick 3. Trick 3 is also used to find all the squares between 11 and 99. We have to find the square of 23. So 23 is equal to 20 plus 3. It means it is 3 more than the nearest integer which is divisible by 10. Then we have to calculate 20 into 23 plus 3, the amount which it is exceeding. So 20 into 26, 20 into 26 is equal to 520 plus 3 square, the unit digit is square, so your result is 529. 87 square, 87 is 3 less than 90, so 87 is equal to 90 minus 3. Now what we have to do is 90 into 87 minus 3, 84. So we have to do 90 into 84 plus 3 square. So we will get 7569. Now answer to the question, up to which number square should I remember? Majority of questions asked in the exams use a square between 1 and 32. So what I suggest is that you should follow trick 1, that is finding the square of numbers ending at 5 and remember the square of numbers between 1 and 32. Do not waste your time on learning a lot of tricks, as when you face a question in exam, then under pressure of time you will forget to utilize these techniques and go back to the basic rule of multiplication. Now let us move towards computation of a square root of numbers. Trick 1 can be used to compute the square root of a perfect square integer only. For example, 36, 225, 49, 64, etc. This concept depends on unit digit calculation. As we can see from the table that if any number unit digit is 0, its square unit digit will also be 0. For example, the square of 10 is 100, 20 is 400, the unit digits are 0. If a number unit digit is 1 or 9, such as 31 or 89, then its square's unit digit will also be always 1. If a number's unit digit is 4 or 6, such as 24 or 66, then its square unit digit will always be 6, and similarly for other unit digit according to the table. So we can conclude that a number will be perfect square if and only if its unit digit is 0, 1, 4, 5, 6 or 9. Now let us try computing the square root of 5329. As one can say that 5300 lies between 4900 and 6400, so the square root of 5329 will lie between 70 and 80. Now we can compute the square of 75 by the technique 7 into 8, 56, 56, 25, 5625. The square root of 5329 should lie between 70 and 75, and since its unit digit is 9, so the unit digit of the squared number should be 3. Therefore the answer is 73, or 73 square is equal to 5329. Now let us try to compute the square root of 1521. Since we know that 1521 lies between 900 and 1600, therefore our number will lie between 30 and 40. Now square of 35 is equal to 3 into 4, 12, 1225. So we can say that the square root of 1521 lies between 35 and 40. Now what it can be? Since unit digit of 1521 is 1 and the number should lie between 35 and 40, so the unit digit can be 9. Therefore our number is 39. At last, let us try to compute the square root of 3136. Now 3136 lies between 2500 and 3600, so the number lies between 50 and 60. We can compute the square of 55. Square of 55 is equal to 5 into 6, 30, 3025. 3136 is greater than 3025 and the unit digit in 3136 is 6, so the number will be 56 and the square root of 3136 is equal to 56. Now we will compute the square root of any integer. So for example, if we have to compute the square root of 147, so we can say that since the unit digit is 7, so it is not a perfect square. So how can we compute the square root of square root 147? So the trick is as follow. At first, using trick 1, find the nearest lowest integer. Since we know that the square of 12 is 144, so the nearest lowest integer is 12. So the answer of our first step is 12. Step 2 says find the difference between the perfect square of first and the number. Means 12 square is equal to 144. So the difference between 147 and 144 is 3. So the value in step 2 is equal to 3. Now step 3 says divide the result in step 2 by 2 times result in step 1, that is divide 3 by 2 into 12. 3 divided by 2 into 12, that is 3 by 24, is equal to 1 by 8, approximately is equal to 0.14. So the final result, your result will be step 1 plus step 3, that is 12 plus 0.14 is equal to 12.14, which is approximately equal to the exact value, which was 12.12. Let us try to understand it using another example. Let us try to compute the square root of 29. What is the perfect square which is just less than 29? 25. Now 29 minus 25 is equal to 4. So what we will do now, 4 divided by 2 times 5, that is 4 divided by 10 is equal to 0.4. So our result will be 5.4, which is approximately equal to the exact value 5.38. Let us compute one more example. A square root of 550. Which number is closest to the 550? As we can say that 23 square is equal to 529. So our perfect square is 529 and our number is 23. Now 550 minus 529 is equal to 21. So what we will do now, we will divide 21 by 2 times 23, that is 21 by 46, which will be approximately equal to 0.4. So our result is 23.4, which is approximately equal to the exact value of 23.45. This is a very important trick in order to calculate the square root and in order to solve the approximation problem. So try to revise it again and again. Majority of the questions which are asked based on cubes can be generally solved by remembering the cubes up to 11. If a question has been asked to find the cube of say 37, so what should we do? See, as we can see from the table that each number cube have different unit places. For example, the cube of 2 is 8, 3 unit place is 7, 6 unit place is 6, 9 unit place is 9, 8 unit place is 2, 7 unit place is 3. We can conclude that the cube of a number have distinct unit places. So if someone asks you the cube of say 28, then you will select that option which has ending of 2. If someone asks you the cube of say 97, then you will select that number from option which ends with 3. And so now we will discuss a trick by using which we can exactly calculate the cube of all the numbers between 11 and 99. Okay, let us try to understand this trick with help of an example. Let us try to find the cube of 21. So 21 cube, what we have to do is we have to find at first a cube. 2 cube is equal to 2 to 4 to 8. Then we have to write a square b, that is 2 square into 1, which will be equal to 2 to the 4 into 1 equal to 4. Then a into b square, that is 2 into 1 square, that is 2 into 1 equal to 2, and then b cube, that is 1. Now what we have to do is, we have seen 4 and 2, we have to multiply them by 2 and write it downwards, that is 2 into 4 is equal to 8 and 2 into 2 is equal to 4. Now we have to add them column wise and we will get our result. At first write 8, 4, 2, 1, then we will write 8 below 4, then 4 below 2 and add them column wise. So the result will be 1, 4 plus 2 6, 8 plus 4 12, carry 1, 8 plus 1 9. This was easy. Now let us try to compute the cube of say 37. So first what we will do, 3 3 ja 9 3 ja 27. So 27, then 3 square into 7, that is 3 3 ja 9, 9 into 7 is equal to 63. Then 3 into 7 square, that is 3 into 49, that is 147, and then we will find 7 cube, that is 343. Now what we will do, we will multiply 63 by 2, so 126, and 147 by 2, that is 294. Now we have to arrange it in following order. At first what we will write, 2 7 we will write, then we have to write 63, so only one decimal places we will write 3 and 6 will go above 7. Then we have to write 147. So after 3 we will write 7, then 4, then 1 above 6. Then we have to write 343. Then we will write 3, then above 7 4, then above 3 3. Then we have to write 126. Now 126 is 2 times 63, so it will start from 3, from the box below 3. So 1 2 6. Then 294, then 294 is 2 times 147, so it will start with the box below 7. So 294, then we will add them column wise. So the result will be 3, 7, 4, 11, 4, 15, carry 1, 9, 1, 10, 6, 16, 3, 19, 4, 20, 3, 3, 26, carry 2, 2, 2, 4, 2, 6, 6, 12, 7, 19, 120, carry 2, 2, 2, 4, 1, 5. So the final cube of 37 is equal to 50653. The trick to find cube root is very easy, and you should by heart this trick, because this trick will be quite helpful in solving various questions. So one more important observation which we can gather is, if the number is 4, then unit digit of the cube will also be 4. If the number is 5, then unit digit of the cube will also be 5. If the number is 6, unit digit of cube will also be 6. And if the number is 9, unit digit of cube will also be equal to 9. And for other numbers, for example, if the number is 2, the cube unit digit will be 8, and 8 plus 2 is equal to 10. If the number is 3, the unit digit of cube equal to 7, and 3 plus 7 equal to 10. If the number is 7, its cube unit digit will be equal to 3, and 7 plus 3 is equal to 10, and so on. So what we can conclude is that if the numbers are 1, 4, 5, 6 or 9, the unit digit of their cube will be same. Otherwise, sum of the unit digit of the number and that of the unit digit of the cube will be equal to 10. Now, using this concept, we will try to find the cube root of 21952. At first, do what? Separate it into two parts, 21 and 952. Why 952? Because as we can see that the cube of 9, which is the largest possible single digit number, is 729, which is 3 digits. So always separate it into two parts, the first 3 digits into one part and rest into another part. Now 29, 21 and 952. From 21, what we can guess that 21 lies between 2 cube and 3 cube. 2 cube is equal to 8 and 3 cube is equal to 27, and since it is 952 and 8 plus 2 is equal to 10, so our unit place will be 8. Hence we can say that our result will be 28. Now let us try to find the cube of 157464. Again, dividing it into two parts, 157 and 464. Now 157 lies between 5 cube and 6 cube, and the unit digit of 464 is 4, so our result will be 54. Let us try to solve some previous year questions based on the concepts what we have learned. This question was asked in year 2015 in IBPS PO preliminary. At first, whenever we attempt such question, try to remove the question mark with some variable. Here we remove it by the variable named y. The square root of 575 is equal to 24. So 24 divided by y into 225 is equal to 450. By cross multiplication, we can say that 450y is equal to 24 into 225, or y is equal to 24 into 225 divided by 450. Therefore, y is equal to 12. Let us try to solve this question. This was also a question based on approximation. We can write it as 1439 divided by 16 into 15. So 15 by 16 will be approximately equal to 1. So the number y will be approximately equal to 1439 into 1 plus 17. So we can say that the approximate value of y will be equal to 1457. So the closest value is option number D. The next question was asked in SBI clerk preliminary in the year 2016. Taking y to one side, we can write y is equal to 10,000 minus 3600 divided by 25. Taking 100 common, we can write y is equal to 100 into 100 minus 36 by 25, or 4 into 64. Therefore, final value of y is equal to 256, option number E. The question was cube root of 17.576 into 15 is equal to question mark. So at first we will try to find the cube root of 17.576, separating it into two parts, 17 and 576. We can say that 17 lies between 2 cube and 3 cube. Cube root of 17.576 will be equal to 2.6. We can compute the value of y as y is equal to 2.6 into 15 is equal to 39. Next question was asked in IBPS PO Mains 2016. This question can be solved as follow. Y, the approximate value of y is equal to square root of 360.98, means approximately equal to 19 into 19, 18.99 we have approximated it as 19, plus 1082 is divisible by 19, so we can write it something as 57 into 19 and divided by 57. We have approximated 57.07 to 57. Now we can solve it as y is equal to 19 into 19 is equal to 361 plus 19 is equal to 380. So our option will be option B. Next question was asked in IBPS Clerk Preliminary 2016. Here we have to find the cube root of 35937, which can be found using our shortcut. So 35 lies between the cube of 3 cube is equal to 27 and 4 cube is equal to 64, and last value is 7. So cube root of 35937 is equal to 33. Now 33 into 1331. So what I can write as 33 into 11 into 11 into 11 divided by 121, that is 11 into 11. So finally we will get y is equal to 363. This question was asked in IBPS Clerk Preliminary 2016. How can we solve it? See, the cube root of 9261, we have to divide it into two parts. One part is 261 and another part is 9. 9 lies between 2 cube and 3 cube. Therefore, the cube root of 9261 will be equal to 21. Now, square root of 6274 2241. As we can see that the unit digit in the given number is 1, so the result of the square root will also have 1 or 9 at unit place. So what we can say that the question is reduced something as 21 multiplied by some number whose unit place is 1 or 9, which will result at something at 1 or 9 at unit place, because 1 multiplied by any number will be same number, so the unit place will not change. Now our y is equal to 1 or 9 at unit place minus 89, that is 9 at unit place. So if 1 was at unit place, so 1 minus 9 is equal to 2, or if 9 was at unit place, then 9 minus 9 is equal to 0. So our answer can be either 0 or 2 at unit place, but from the given option only 2 is at the unit place in option number D. So our option will be option. In order to solve this question, the first square root, which is most inside, should be solved, and then we should come outside. So at first we will solve the square root of 225, which is equal to 15, and 15 plus 561 is equal to 576. Then the square root of 576 is equal to 24, and then 337 plus 24 is equal to 361. So square root of 361 is equal to 19. Therefore we will get y is equal to 72 minus 19 is equal to 53. Thank you for watching this video. For more videos, please subscribe to our channel Bankers Rankers. Please give your suggestion in the comment box and click on the like button if you liked our video.